So number 4, we've got a box with a square base. 4 in the handout here. And an open top. And its volume is 3 feet cubed. Find the dimensions that will minimize the amount of material used. So summary. Not summarized, okay. So we've got a box with square bottom. Box with square top. Square bottom base. Yeah, get it right here. Box with square base, open top, volume 3 feet cubed. What's the dimensions that minimize the material? Oh, and I didn't, okay. So minimize the material. Well, let's test our little drawing skills here. So we got a box. My rendition. Got a square base. So that means this, the length and the width, let's call it, are the same. Both of them are x. Now in a box, you have 3 dimensions. You got the length and your width and then your height. Well, it doesn't say anything about what the height could be. So the length and the width, it has to be the same because it's square base. But the height doesn't have to be the same. So that we have to call that a different dimension. We'll call it y. Okay? Now it doesn't have a top, so we draw that in. Just kind of. All right. We want to minimize the material used. So I need a material equation. Well, the material used is just all the sides, the area of all the sides put together, right? So the material used is just the area of all the sides added together. With me there? So I'm just going to find the area of each of the sides. That'll be my material use. So this area plus this area, back, left side, and there's the bottom too, okay? All right, well, let's start with the front. The front here, what's the front area? Well, I've got an X by Y rectangle. So the area of that front is going to be XY. Now, let's make this as easy on us as we can. What do you notice about the other sides? What's the left? Right. Sorry, other way. What's the right side area? It's an X by Y rectangle also. So there's a second. What's the back? XY, and then the left side, an XY. So there's 4 XYs. So the front, back, and sides, the areas are all XY. So there's 4 XYs. Let's just put that in. What does that leave? The base. What's the base? The bottom. Well, it's an X by X rectangle square. It's a square. So the area of that is X squared. And we don't have a top, so there's just one of those, X squared. Okay? So far so good. That's the material equation. Well, guess what? You got 2 variables there, so we need a second equation. And that would be the volume. The volume we know is 3 feet, but what's the volume of this box? Well, the volume of a box is length times width times height. The length is X, the width is X, and the height is Y. So we've got XXY for the volume. Like we said, that's 3. We know the volume's 3. So we've got 3 equals X squared Y. Simplify it as much as we can. Now what do we do with that? Well, that gives me a way, since I want to minimize the material, I need to do the derivative, but I've got 2 variables. Don't know how to handle that. 2 variables yet. So we need to get it down to one variable. That's where this equation comes in, right? I can get this equation, solve for one of the variables, and put it over there. Now, looking at that, which one would be easier to solve for? The y, right? Just divide by x squared both sides. 3 over x squared is y. Then I can substitute that for y in the other equation. Same old thing. We've got m equals 4x times y. Y is 3 over x squared. Substitute that in. Now this left part here, well, that x will cancel one of those x and the x squareds out, so wouldn't this be 12 over x here plus x squared? And for purposes, I'm trying to minimize this derivative. For purposes of derivative, I'd probably write that as m equals 12x to the negative 1 plus x squared. Yes? Get the derivative. I mean negative 12x to the minus 2 plus 2x. Get the derivative. I want that equals 0. That's negative 12 over x squared plus 2x equals 0. Again, I like it where the exponents are not negative, so flip that one over. The way I've been showing you is, with that, multiply both sides by that x squared, clear out that denominator. Yeah, that times that, then the x squared will cancel, it'll be minus 12. X squared times 2x would be 2x cubed. And then of course 0 times anything is still 0, so yeah, makes it a lot nicer equation. All I have to do there is add the 12, divide by 2. X cubed equals 6, and so x would be the cube root of 6. Again, I want the dimensions. That cube root of 6 is the x here. That would be the length and the width. That would be feet. Cube root of x, cube root of 6 feet. What's the y? Well, the y is right here, 3 over x squared. So it'll be 3 divided by the cube root of 6 squared. You know, you can do that. Cube root of x is cube root of 6. Why do I keep saying that? Cube root of 6 is 6 to the 1/3 if you can't find your cube root button. So 6 raised to the 1/3 power. It's about 1.817. That's some feet. And so that would be 3 divided by that squared. What you get there. Yeah. About 0.909. Right, that's it. Because I wanted to show you there. You can, if you do a little work there, you can kind of find out that, you notice how those look like they're related? That's about twice as big as that, yeah. So anyway, there's usually a relationship like that. All right, got one more. Is that okay? Any questions on that? Okay, number 5. Last but not least. A box is to be made from an 8 by 15 inch piece of cardboard. Rectangular piece. What's that right there? So we got a piece of cardboard that's 15 inches by 8 inches. That's what we got. And we're going to cut. We're going to make a box out of that by cutting squares out of the corners. Same size squares out of the corners. So cut a square there, cut a same size square there, same size square there, there. And the way that works is then, yeah, we'll take those out. And then we can fold these flaps, fold the flaps then up, ends there up. So just fold those flaps up and you wind up with a, well, something like this, right? That way. Box. An open top. Hopefully you can kind of visualize there. Okay? All right. So, what's the problem? What's the largest volume that box can have? Well, obviously, you need a volume equation. Length times width times height, it's a box. So the volume here is the length times the width times the height. Well, that really doesn't do me much good to leave it as those terms. So let's put it into the things here. What it all hinges on is that square I cut out, isn't it? And so let's call that square I cut out x, dimensions wise. So this is going to be x, x. So I've got little squares, x by x squares cut out. Okay? Well, how does that translate over here then? Well, if I look at the length there, the length comes from this piece, which is this right here. How can I write, because 15 is from here to here. How could I get this piece in here? Well, each one of these is x by x, right? They're all the same square. So if this is 15, then what is that from there to there? 15 minus 2x? 15 minus 2x. So that's my length, 15 minus 2x. Same idea on the width. The width of this box, this is going to be the width right here. From here to here, this far. Well, this is 8 inches. I'm interested in this piece, so what is from here to here? If that's 8, then from here to here would be also 8 minus 2 x's, right? Got 2 inches, 2 x's out of that. So the width is 8 minus 2x. And what's the height? Well, the height of this box is just, when I flip those up, the height is going to be this right here. Didn't it? That would give me my height. I flip that up. Whatever that is the height. So what's the height? Height's x. Make sense? So the volume is 15 minus 2x times 8 minus 2x times x. The good news on this one is I just have one variable to start with. Well, I guess technically I had 3 variables to start with. When I plug in my x equations, now I just have one variable. So I'm in good shape. I don't have to do any substitution, any more substitution. I just got to figure out the largest volume. Well, where does the largest occur? Well, depending on the problem, it's at the critical number, right? The derivative equals 0. So I need to figure out the derivative here. It's doable there. We usually don't do it though. For one like this, a derivative off of that, it's not that bad. But go ahead and multiply that out, and then think about the derivative. Multiply these two. The volume is 15 times 8 would be 120. Help me out there if I'm doing it wrong. 15 minus 2x minus 30x. Minus 2x times 8 is minus 16x. Minus 2x times minus 2x plus 4x squared times the x. So you got 120 minus 46x plus 4x squared. Then you multiply the x, so multiply that all in. So you got the volume is 120x minus 46x squared plus 4x cubed. Multiplying all three by x. Right? Now the derivative is not that. It's 120 minus 92x plus 12x squared. That's my derivative. Why does that help me? Well, I'm trying to find the critical numbers, which that's derivative equals 0. Which you could go to the quadratic formula there. Let's turn it around first. With the x squared first. So yeah, I could go to the quadratic formula. However, I believe this divides by 4 at least. Get rid of that. So it'll be 3x squared minus 23x plus 30. And again, you could use quadratic formula there, but it does factor. 3x and x. Let's see, 30, I believe it's not 10 and 3, I believe we're going to use 6 and 5. Does that work? That's minus 18x, and that's minus 5. Yeah. All right, well, so that means we got 3x minus 5 equals 0. And x minus 6 equals 0. This is the first one we've had where we had two options. So 3x equals 5, divided by 3, x is 5/3. And then x is 6. 6. Well, which makes the volume the largest? Well, in this case, we can make our distinction here because if I plug in x to be 6, I run into a problem. If x is 6, the height is 6, but what's the width? 8 minus 12, negative 4, negative width. That's no good. So that x equals 6 does not work, so our maximum is, what was the question? What's the largest volume? All right, so the largest volume happens when x is 5/3, so the largest volume would be, wants to compute it here. Well, it's we can either compute it here or here. Take your pick. However you want to compute it. Use this one or this one. Plug in x to be 5/3. Let's plug. So it'll be 120 times 5/3 minus 46 times x squared, so it'll be 5/3 squared, plus 4 times 5/3 cubed. What does that do? 120 times 5/3 minus 46 times 5/3 cubed squared, 25/9. And then plus 4 times 5/3 cubed. 90.74. So I get largest volume. Yeah, that makes sense. 2,450 over 27 to be exact, but inches cubed. Cubic inches. Yes?